Now let's just talk about the another important concept of a circle, which is nothing but called as the perpendicular from the center to a chord. So let us suppose if we just perform an activity in which we are drawing a perpendicular from the center to a chord, then what can we say about the chord? So this is nothing but actually leading us toward an important theorem which is related with this concept, which is nothing but called as the theorem which says the perpendicular from the center of a circle to a chord always bisects the chord. So now we just have to prove this thing. So let us suppose again, if I'm just drawing up a circle over here, so let if we have this circle, let us suppose we have this circle with us, and if I'm just taking this as nothing but the center of the circle. So let us suppose if I'm just taking it as nothing but a center of the circle, and I'm just taking this as nothing but a chord, and I'm calling it as nothing but AB, such that if I'm just forming up a perpendicular over here, I'm calling this as nothing but X, and I'm just doing a little bit of construction such that I'm joining this and this all together, and I'm calling it as nothing but O. So as per the given conditions, I'm just saying that we have a circle with the center O, and OX perpendicular to AB. So we have done a little bit of construction over here. So what is that construction? Construction was like join OA and OB. Now what we have to prove over here? We have to prove that AX is equal to XB. Now let's just start with the proof. So first of all, as we can see over here, we have the two triangles over here. So in a triangle OXA and triangle OXB, first of all, OA is nothing but is equal to OB. Why? So because they are nothing but the radii of the circle. Furthermore, OX is nothing but is equal to OX. This is nothing but the common side in both. And further, we know that the angle OXA is nothing but is equal to the angle OXB, because each is nothing but 90 degree. Each is 90 because this is perpendicular, so this is also 90, this is also 90. So hence from these three things, what we can say? We can say that the triangle OXA is actually congruent to the triangle OXB by RHS congruence criteria. We can say this thing, that the two triangles are congruent, and if the two triangles are congruent, then definitely AX is equal to XB by CPCT. By CPCT, AX is nothing but is equal to XB, or we can say that this is nothing but is equal to this. And this is exactly that what we have to prove over here, that the perpendicular from the center of the circle to a chord always bisects the chord.